All right, series example 4. We're going to decide whether or not this infinite sum converges or diverges. Like I talked about in the last video, this infinite series converges if and only if this improper integral converges. And similarly, it diverges if and only if its associated improper integral diverges. Okay, so that tells us what to do. So what we're going to do is we're going to look at 1 to infinity 1 over x squared dx. All right, so remember our way we do this is we replace infinity with a finite number r and compute the integral. All right, so 1 over x squared, bring the x squared up, making that an x to the negative 2. All right, then add 1, divide by that amount. That's the antiderivative. Let's see, negative 2 plus 1. Negative 2 plus 1 is a negative 1. Divide by negative 1 from 1 to r. All right, I'll do some simplification here. 1 to r. And this is, let's see, got negative 1 over r minus negative 1 over 1, otherwise known as negative 1 over r plus 1. Just to make it look nice, I'm going to call this 1 minus 1 over r. All right, so this integral is equal to the limit as r approaches infinity of 1 minus 1 over r. You can see that as r gets large, 1 over r goes to 0, and this equals 1. All right, so this converges, Now we can't say necessarily that because this is a 1 here, that this thing converges to 1. We don't know that. We do not know that. All we can say is if this converges, then that converges. This converges to 1, so we know this guy converges.